You guys can say hi.
Can I draw f prime of x on top of the
Hi, Joyce.
Hi, Joyce.
What they're doing right now is they spent about 30 minutes?
4 minutes.
They spent about 30 minutes just working on homework number 7, section 3.1 and 3.2 right here. Because, ooh, hey, that's cool. Because if you look at our calendar, if you have our stuff open, our calendar for BC is going to go pretty fast in the sense of we're going to have a test next Thursday on chapter 3, and we're going to combine stuff. So today our goal was 2 different sections, and then Monday is 1 section, Tuesday is 2 different sections, Wednesday review, oops, there it is, Wednesday review, and then Thursday test. So as such, we're going to do things a little different because we should be able to go fast. Instead of going straight to notes, we're going to go straight to homework instead. And they've been working on homework. Right here, go ahead and pause it to write it down. Work on it for about 30 minutes, and then come on back, and we're just going to write down a few notes to summarize what's going on in these 2 sections. Okay. Everybody else, composition's open. We're just going to write down a few things, not much. Tonight's homework is finish. There are 2 different pages. You guys are almost done with 3.1, yep? And a couple questions, but working through it together, we're able just to kind of hash it out so we can go fast. Sound good? So we'll go over questions tomorrow. Yeah.
Do we write 3.1 through 3.2?
Uh-huh.
Okay, cool.
Yeah, we're just going to have one section for 3.1 to 3.2. We're in chapter 3. Long story short, 3.1 is derivatives, the introduction, like tangent lines, etc., as you guys could tell. And then section 3.2 is going to be differentiability. I literally have 3 slides, so we're going to go fast. And it's basically just writing down the highlights.
Is this whole year going to be like this? Combining sections?
Just to get through basic derivatives.
Okay.
I'm sure when we get to like related rates and whatnot, we'll slow down for a day and have some AP FRQs and stuff, just because we could always use more practice on that. And optimization as well.
Are we going to start doing numbers? Or
We technically have like 2, but I haven't gotten online and I was feeling like junk last night, so
it's okay.
lo siento. Give me a weekend.
Because when you have to do it, then we have to do it.
True, good point. Slope of the tangent line is the, how would you guys fill in the blanks? Let's see if you remember.
Is the derivative?
No. That is the derivative. The derivative is the slope of the tangent line.
Slope of the tangent is the differentiable?
Is this?
Is the,
What is this? The slope of the tangent line is the blank with the slopes.
Limit?
yes.
Oh, first try.
Is the limit, third try. Is the limit of the slopes of the secant lines as
X
the removal?
Or yeah.
X goes to 0, sorry, delta x goes to 0, or x goes to the point of tangency, which could be like a or c or whatever. So then definition of derivative, if they ask you or I ask you to use the definition to solve, which remember, of course, we're going to our rules, and that's one of the reasons we're going so fast. It's because you guys know the rules. But we still cannot lose grasp of the definition itself. And of course, this is just a simplistic version where h is equal to delta x, just to make it easier for solving purposes. But you guys know, if you plug in, you get 0 over 0, true?
Yes.
So then how could we, if we did need to solve one of these the long way, what can we use that you guys learned last year since you know derivatives? L'Hopital's. You could use L'Hopital's if you needed to actually solve one, but hopefully we'll see it as a derivative and just take the derivative and not need to worry about it.
Misty, if we do L'Hopital's, there's 2 things to derive because you have to
True,
put
I'm not
h.
saying it would be nice necessarily, but instead of having to like multiply by the conjugate, simplify a complex fraction, and that annoying stuff, like maybe L'Hopital's would be easier based dependent on what you have.
How do you derive an h? I can't just. That's not just doesn't go to 1, does it?
H is a constant? Oh, good question.
Wouldn't h be a variable, so x is not what we're actually like?
No, h is
Technically,
We'd be deriving in terms of,
h, not x anymore. So then,
that's a good question. Huh.
because on the bottom, like
0 to 0.
it'll be h on the bottom always. So how do you let L'Hopital?
Yeah, I have to think about that. Problem solving clue. Find the derivative at a point. Nice thing is I think we just wrote this down a few days ago, and that there's 2 different variations. could either have x approaching the constant, which could be something like a, and you could have your f of x minus f of a all over x minus a. That's one variation. What was the other one again? How to actually find the derivative at a point using the definition?
F of, oh, you already did it. Oh, f of h plus a
Yeah,
minus f.
I'll do
f
a
of
plus
x,
h, but
f of minus f of a over h.
and the limit would be to make it 0 over 0?
H equals, is equals to 0.
As h approaches 0. So it's just like the definition, but instead of x we say as x approaches a. And each of those are just different variations of f prime of a. Okay. Oh, I have it twice. Finding the equation of the tangent line. I guess you don't need or normal line, that's the next one. Cosine. Point slope. Y minus y1 equals, and what do we do in lieu of the m? F prime of?
A.
Yeah, we'll say x1, second.
Yeah.
We could do f prime of a. We could have something like y minus f of a equals f prime of a times x minus a. If you like that a little bit more, I guess it's a little bit nicer. And then how do we change that if it's a normal line?
1 over f of negative,
Yeah, negative, opposite reciprocal, good. So it'd be everything is the same, and this, George, was your question in the sense of, if you know the point of tangency, you're still using f of a, you're just doing negative 1 over f prime of a times x minus a. Pretty much that sums up 3-1, right? Using the definition, some of you are cheating using power rule, I don't mind. So what's 3-2? Oh, we had one more page. But it's okay, you guys have already seen it. Yeah, that's the homework. So we'll just write this down fast on Monday. But I think you guys are okay. Yeah, I still do. Remember, if it's not differentiable, you either have vertical tangent lines or sharp points. We're just going to write down on Monday what you guys hopefully pulled out of homeworks that you did in chapter 2, because you guys had to think of when was it vertical, when was it sharp. And in homework, it's going to have you dig a little deeper in cusps and corners. That'll be fun.
If we say sharp points, maybe like jumps too? Like differential at jumps?
Discontinuities can be jumps, but jumps in the derivative would be sharp points of the original.
No, I mean, it's like a function is not differentiable at a jump.
No, it is.